Hi, welcome to another tutorial. This is how to get some LEDs working like a chase pattern, Knight Rider style, but not the exact copy. Yeah, I've just programmed in various patterns, turning various LEDs on and off. Got the PIC processor, PIC microcontroller I should say. Yeah, running this 16F627. Got the 16F627 basically because it's got in-circuit serial programming, which I'll explain in a minute. If you're creating a pattern and want to see if it works, you don't want to have to keep on unplugging the chip and plugging it into your program and taking it back out, etc. So I've just got the 4 or 5 wires, in-circuit serial programming. Keep on changing the program it and see what the pattern looks like. So this is what I've done so far. Thought it was pretty apt seeing how it's Christmas. Yeah, this tree's tinned copper wire. Have to scrape the enamel off where you want to solder the links. The copper wire is neutral, and I've got an even thinner tin copper wire running alive to all the LEDs. Well, I've set my alarm in the background because, as is normal with me, I run out of time, so I'll turn the light on. What you need to know first, well, you're probably wondering how to wire it up. So if I just show you quickly. Rather than using crystal and capacitors, hopefully this is going to focus. You want a ceramic resonator, 4 meg ceramic resonator. The camera's going to fall over. That's a 4 meg ceramic resonator. The 2 outside pins go to your crystal or oscillator pins on the chip, and the centre one is ground. That's what a ceramic resonator looks like. That's my circuit with all the LEDs, resistors I should say. That's the programmer. I normally program 87740 pin chip, so that's what I've got it wired up to. Use the PIC Kit 2. This is actually an emulator, didn't realise at the time. Emulator, another word for copy. So 5 wires, power, program clock, program ground, program clock, program data, ground, power, master clear. Right, here's a drawing how to wire it up. Excuse me while I move this camera and sort my tripod legs out. Well, I haven't got too much time to explain all of this. Right, hopefully you can see all of that. Well, there we go, 220, 330 ohm resistors to all the LEDs. This is port B, RB 0 to 7, so you've got 8 LEDs there. And what for this tree I've got 11 LEDs all in total, so RA0, RA1, RA2 makes up the rest. That's where your resonator goes, pin 16 and 15. Get the data sheet. Master clear. Tight, high, 4.7k resistor up to 5.5 volts DC. I'll be explaining or talking about weights, binary weights, which is this bit. Excuse me. So RB0, 1, 2, 3, 4, 5, 6, 7. Counting in decimal, 1, 2, 4, 8, 16, 32, 64, 128. That's port B. I'll be coming to that later, hopefully if I've got enough time. Well, I'll get the data sheet up, which I've got for you here. So you see there, in-circuit serial programming, 3 to 5.5 volts DC, and that's the chip there. Just download the data sheet. Let me lock this camera off. So as I say, 16F627, that's where your crystal goes. Oscillator 1, oscillator 2, power, ground, master clear is the one we tie high, programming data, programming clock, that's for the in-circuit serial programming. If you get errors programming, it's like your PIC Kit 2 that says device not detected, it could be you've got these 2 pins loaded with LEDs. So just disconnect them when programming if you're having that issue. It was just a quick note. Right, so that was a wiring diagram. Get rid of that. Get rid of that. Right. For all my programming, I'm using Microcode Studio Pick Basic Pro. So this is your basic chase. I'll go to the top in a minute. So you start with the main loop. Right, high naught, pause. So that's literally turning on port B pin naught. Pause for 100 milliseconds, which is a tenth of a second. Then high pin 1, sorry, high port B pin 1, which is actually the second port. Low blah blah blah, high 4, low 3, high 5. You can do it like that, just writing out every code for every single pin. Actually, if I go to the top, aliases, you might see various programs, aliases. What's an alias? So if you look at the top there, hopefully you can see it. No, you can't. I've got LED 8 var port A.0. So if I'm referring to LED 8, the program is automatically switching to port A.0. LED 9, I've got variable port A.1. So I'm turning all these LEDs on and turning the predecessor off and pausing for various amounts of time. If I scroll through this, just copy it down basically. Looks like my battery is running out on this camera. So you can see I'm just turning different pins on and off to get the pattern. If I scroll down quickly, so at the end I want them to all turn off. So I've got port B equals 0, port A equals 0. That turns everything off. Pausing for 400 milliseconds, 0.4 of a second. Right, this is the binary weights I was talking about. Port A equals 7, so I'm using port A 0, 1 and 2. So if we go back to our picture, port 0, 1 and 2 is a decimal weight 1, 2 and 4. So 4, 5, add these three ports up together, 4, 5, 6, 7. Where are we? Port A equals 7, so I'm turning those three pins on. Port B, using the decimal equivalent, turning all 8 pins on. Use the percent sign there. You can just go 1, 1, 1, 1 8 times, turn them all on. You could actually change that to like 255, or if I delete it, put the dollar sign, go FF. That's turning. Press F9 for program, because I've got in circuit serial programming. That's going to reprogram the 627 chip. You hear the noise in a minute when it's finished. Yeah, there it goes. Right, so FF, where I've got this FF from, in case you haven't seen the other tutorials, get the calculator up in, well, this is Windows 7. That's the standard view. Go to Programmer. So if we're working in binary, we can go. We want all 8 pins of port B. 1, 2, 3, 4, 5, 6, 7, 8. So you see there, 8 ports all turned on. Oh, running out of time. Go to decimal, 255, hexadecimal, FF. That's a quick tip for you. I better stop.